I'm the postdoc working on the Chibougamau Transect. I'm gonna jump in right on my presentation because I have a lot of stuff to cover in 25 minutes. Okay, so working on the Chibougamau Transect, which is located in the northern volcanic zone in the Abitibi. So the Abitibi can be divided in two different volcanic zones. The most well-known is the southern one because of the numerous gold deposit that it's hosting. One of the specific features that we are going to talk about today in the southern part and in comparison with the northern volcanic zone is the occurrence of many small fluvial units called the Témiscamingue assemblage or basin, which represent an important time marker in the southern volcanic zone. During this time, there was also alkalic magmatism, and which have influences on how much there is gold in the southern volcanic zone. So just keep that in mind. So now going to the Chibougamau area itself, it's a special location located in the wedge of the Abitibi between the Opatica subprovince and the Grenville province. It encompasses two volcanic cycles with the different shade of greens on the map, as well as many sedimentary units, which are not so much well documented as the volcanic rocks. Whoops, sorry about that. So there is, most of the structural framework is in relation with regional folding, but the red line on the map also highlight limited faulting, mostly occurring on the boundaries on the sedimentary units. We are also going to talk about metamorphism. So when we started the project, we thought that the Chibougamau area was like most of the Abitibi, mostly at green schist faces with some local amphibolite metamorphism located around the tectonic intrusion in pink on the map, and regional metamorphism in orange next to the Opatica and next to the Grenville. And we will see that's changed a bit now. So some of the specific features of the area is the Lac Doré complex, layered intrusion hosting most of the copper gold mineralization in the area, and the coming seals, which are layered and differentiated seals occurring in the upper part of the volcanic pile in the Chibougamau area. So the coming seals and the upper and the second volcanic cycle were previously documented only in the northern part of the area, and we will also discuss that this morning. So since it's have been 3 years since the Chibougamau Transect started, it was the time to look back at what was the objective in the beginning. So most of the objective revolved around the difference between the northern volcanic zone and southern volcanic zone, and why there is less endowment in gold in the Chibougamau area than in the southern Abitibi, and why sand volcanic intrusion are so prevalent in the area. So the mapping part of the Transect mostly focused on the two first objectives, focusing on deformation, metamorphism, and architectures and fluvial basin, which have some connection with orogenic gold deposits. And in 2 days, Lucie Mathieu is going to talk and complete on magmatism, which is really important in the Chibougamau area. So we are currently publishing all of the results. There is already one paper on the Barlow Fault zone and associated metamorphism, and there should be in the next few months 2 papers on Detrital age and igneous age, which are already in preparation. Okay, so the outline in this presentation is we produced a new revised maps of the area, and I will talk about 2 of them more specifically. The Barlow Fault in the north, covering also the Chibougamau basin, and the Caopatina region located to the southern end of the Chibougamau Transect. And I will be also talking about the result of the Detrital zircon age determination we performed in the area. And ultimately, I want to show you the idea of a tectonic model we got on the Chibougamau area, compare it with the northern volcanic zone, with the southern volcanic zone, sorry, and what is the implication for orogenic gold deposits. So coming back at the survey, if you remember, the Chibougamau Transect was one of the few ones where, say, a reflector package can be found next to the surface. So there is two of them. The other one is in direct relationship with the Wakonichi and Barlow Fault system, while the southern package is connected to the Doda and Guercheville fault system. And I just want to publicize that the fact that Said, the geophysicist in charge of the Transect, is right now preparing and in the process of publishing a paper focusing on the high resolution part of the survey, which were located right on top of these two packages. So the Chibougamau area was revisited and using distribution of lithofaces, and we were able to discover that the Blondo formation, part of the volcanic cycle too, was actually in contact in the western part of the basin with the Chibougamau basin. But the most important aspect was the discovery of the Barlow Fault zone, which ultimately led to the revision of this area of to this part of the Chibougamau area. So I've already talked about, a lot about the Barlow Fault zone. So this is just a recap. It has been published from the last time we talked about it. So it can be considered a thrust fault with slivers. And it seems that the fact that there is this sliver, especially of the coming sills, so ultramafic and mafic rigid bodies inside the fault, may have an incidence on why this fault specifically shows so much on the survey. So the reflector package match both in size, in deeping, and in position with the Barlow Fault zone itself. And one of the special thing is the Wakonichi tectonic zone located a bit to the south, shares many similarities with the Barlow Fault zone, both in deeping and orientation, but doesn't show up on the survey, which might be related to the absence of the coming sills inside the Wakonichi tectonic zone. And ultimately, we interpret that the Barlow Fault zone is in fact a splay and is of the Wakonichi tectonic zone and is connected to it at depth. And all of this fault system is in fact a back thrust system which developed during the north-south shortening of the Chibougamau area. And it seems that this thrusting system is associated to the Caopatina subprovince. It's like really close to the boundary between the two subprovinces. So one of the big surprises when studying the Barlow Fault was about metamorphism. We took samples on both sides of the fault, and on the bottom left, this is the old metamorphic map of the area. And we've discovered that both rocks on north and south of the Barlow Fault zone were actually at amphibolite faces. So this means that in fact the amphibolite faces has a more regional spread along the Caopatina boundary, and that the Wakonichi tectonic zone might be the boundary between these two different metamorphic domains. Okay, so now we are going to the southern half of the Chibougamau area, moving for 100 kilometers to the south. So once again, we perform a complete revision of the map using mostly everything we found. So drill hole data and compiled outcrops and even aeromagnetic anomalies to help circumscribe the location of the different units. So there is a lot of stuff happening. The first one is that we provide more details on the Guercheville fault system using all this information, and it can now be considered that like some kind of horsetail or splay along this major east trending structure. Inside this splay, we discovered that the Caopatina, which was previously thought to be only deep marine environment deposit, also contain fluvial sedimentary rocks, and which match the description we can expect of something looking like the Temiskaming. Sorry. And one of the other big surprise was the discovery of lithofacies matching the Blondeau Formation. So the Blondeau Formation is part of the volcanic cycle too. And as I said in the beginning of the presentation, this was not supposed to happen. So before Metal Earth, cycle 2 was only confined to the northern half of the Chibougamau area, but now we think that it actually extends to the south. And this is accentuated and supported by the presence of this pink seal located inside the Guercheville Fault. So these seals are differentiated intrusive, mafic in composition. And we managed, thanks to Mike Hamilton, to sample one outcrop and after 2 tries to get a new age. And so for the purpose of this presentation, we call it the Meston seal. And so this is a differentiated seal with lots of similarities in faces with the Bobo seal from the Cummings intrusive suites, which intrude the volcanic cycle too. And the age 2717 is compatible with the exact same age of the Bobo seal. So this means that in the Caopatina region, the cycle 2 is actually present in the area. And more surprise in this area, we also try to get an age in this felsic unit located on the southern lip of the Caopatina region. So in the beginning, we were expecting to get an age similar to the felsic unit on the north of the Caopatina basin. So the same unit on 2 different limbs. So it was supposed to be Wakonichi age at best, or even something older. So nothing younger than 27, 28. And it's really a big surprise and astonishing because the result, 2714, is younger than every volcanic rocks known in the Chibougamau area, but it's still older than every sedimentary rocks. So it's a very specific volcanic environment which is not yet matched to anything in the Chibougamau area. So roughly, this means that everything we thought we know in the Caopatina region, in the southern part of the Chibougamau transect, is actually not so true and need to be revised furthermore. So the only clue we have about this volcanic cycle, this new volcanic cycle, is that it matches the urban Barry stratigraphy. So now I'm going to talk about the Detrital zircon determination we perform on many sedimentary units in the Chibougamau area. There is 4 big units in the Chibougamau area. The Chebistuan and Stella Hui are fluvial environment deposits, so they are expected to get the same age. And while the Bordelot and Caopatina formation are turbidites and were expected to have other different age. So previously there was only 2 units, the Stella Hui and one part of the Caopatina region, which were dated. And so what we did was target 14 locations to get Detrital age. Of these 14, only 9 provided enough suitable zircons to perform the age determination. And for each one, we try to have several hundreds of grains per sample to get a statistic approach of it. So the objective was to find if there was any difference between the age of deposition between the northern and southern volcanic zone, to see if the different environments reflect different age, and if the Barlow and Caopatina sedimentary units were actually true synvolcanic sedimentary rocks. Once again, everything is different from what we thought. So the two histogram on the left is for a deep marine environment, and the two on the right is for fluvial sedimentary rocks. And all units are deposited at the roughly same time. They deposited in the same bracket of time between 2690 and 2705. So there is a bit of variation between all of them, but what is really important is that everything is post-volcanic. So the volcanism ended mostly at 2720 in the Chibougamau area. So all of the sedimentary rocks have roughly the same age. And in the case of the fluvial sedimentary rocks, we can see that some of the sources come from outside the Abitibi. The Chibougamau area has a maximum age of 2790, but we still have older component, and this component match with the magmatic age in the Caopatina subprovince. So the fluvial deposits, especially the Schebistuan, which is really large, seems to be directly correlated to the presence of the Caopatina subprovince next to the Chibougamau area. So we can expect that the Caopatina sustain a large-scale regional or regional-scale erosion and provide a lot of material for the fluvial deposits. So, yeah. So now if we compare it with the southern volcanic zone, well, in the northern volcanic zone, we have this big, large basin, mostly the Schebistuan, but also the Caopatina and the Opemiska, which are continuous and seems to be bigger as we approach, when talking about fluvial environment, when we approach next to the Caopatina subprovince. In the Abitibi, in the southern volcanic zone, fluvial environment are much smaller and are discontinuous units, which might actually highlight local uplifting and erosion along the main breaks. So the message here is, when in the Abitibi, finding fluvial sedimentary rocks doesn't mean necessarily that they are Temiskaming groups, so in the lithostratigraphic sense, or nor Temiskaming assemblage, so in the chronostratigraphic sense. They can be different. And in fact, in the case of the Chibougamau area, maybe we can refer to the sedimentation as the Opemiska event. So trying to assemble all these puzzle pieces, we try to create a tectonic model. So coming back to the survey can be divided in the subsurface domain where there is not many reflectors, the middle part of the survey where there is a lot of nerve deeping reflectors, and then the lower one where once again there is not so much reflectors. So all of this can be interpreted as the part of the accretion or collision between the Chibougamau area and the Caopatina. So the Caopatina is thrusting over the Chibougamau area, but the upper part of the Chibougamau area is actually back thrusting over the Caopatina in a crocodile-like structures. This back thrusting is performed by the Wakonichi tectonic zone and the Barlow Fault zone. So before the current erosion, maybe the area was looking like that, with some kind of high relief, providing by erosion a lot of material to the fluvial environment in the Chibougamau area. So the Schebistuan basin would have been there approximately at the feet of these reliefs. And maybe because we have the new age on the southern half of the Chibougamau area, which match with the urban Barry greenstone belt, maybe both this area were in the past connected. But now the mid-crust is actually showing up and is occupied by the Hebert-Neising dome. And what we saw on the ground, what we see on the ground level now is an isolated Chibougamau area versus the urban Barry greenstone belt. So trying to compare it with the southern volcanic zone, well, the northern volcanic zone is much more older than the southern volcanic zone. There is no Temiskaming event in the northern volcanic zone. So maybe something more like an Opemiska event, but this is not the same processes and this is not the same environment. And most of the Chibougamau area can be explained only by using folds. But in the southern volcanic zone, faults are much more important because they bound different volcanic assemblage which are stitched together. And all of this provide new information and implication for gold. So we remember that the Chibougamau area is mostly known for its magmato-hydrothermal copper-gold mineralization. And the Barlow Fault zone at first seems to be a good prospect for gold deposition along it, but we can see that when comparing with more important Crystal-Cale Fault zone in the southern volcanic zone, that it lacks several important parameters which are beneficial for the creation of gold deposits. But there is the special case of the Wakonichi tectonic zone, which might actually be more interesting because it fits more with the parameters established in the southern volcanic zone. And to finish, I want to speak a bit more about the Caopatina region, which have been, in my mind, quite forgotten in the history of the Chibougamau area and still has a lot of prospects. So just this map is showing the gold deposits and occurrence next to the in the Caopatina region. And right now there is several projects and closed mine in this area, which are important. So there is the Philibert project by Sokem, the Nelligan project by IM Gold, and there is the all gold mine called Joman. And all of three are associated to the Gersheville and Doda fault system. And now using the revised map, we can see that in this area, faulting is really important. And we are the same kind of environment than in the southern Abitibi with a small scale fluvial units located next to the fault system. And there is also the Azar Pluton, which is expected to be a syntectonic intrusion. And an MSc student just finished less than 1 month ago working on the Philibert project, and he showed that the Philibert project is actually a mix between metamorphic and magmato-hydrothermal gold deposits.
Hey Pierre, you got to wrap it up. Okay.
Just in time. So in conclusion, I think it was still a success. We managed to provide new detailed map in forgotten part of the Chibougamau area, provide a lot of new uranium lead age for previously both sedimentary and volcanic formation, especially the sedimentary ones, but there is new age coming from the Blondo, and there is the Fouet member that I talk about, which is much younger than expected. This provides a new map of the cycle in the area. So you can see now that the volcanic cycle 2 is showing up at the minimum in the Caopatina region. And there is the Fouet cycle, which postdate volcanic cycle 2 in the Chibougamau area. Same thing for metamorphism. Now we can see that the amphibolite phases is much more widespread at the global scale. And all of this highlight the difference between the northern and southern volcanic zone, both the architectures in tectonism and ultimately on the impact on metallurgy. So I want to thank IMGold Corporation for providing access to the Nelligan project, and Sokem and Mines Royales Québec for providing access to a drill hole in the Philibert project. Thanks to Jeffrey, David, and Ben for helping me with the zircon in sedimentary rocks. I don't think I would have been able to do all this stuff without all my loyal geologists on the field. And thanks to Patrick Hull for providing help for the Quebec Geological Survey, and ultimately thanks to my two MSc students, which were not part of the Metamorphism project, but still worked on some mineralization project in the Chibougamau area and really helped me to understand what was happening. So, thank you.
Okay, thank you very much, Pierre. We have time for a couple of questions. There's nothing in the chat room.
Yeah, it's still a bit too soon in the morning.
Could be. I've got a question. How did the MT and the gravity, you didn't show any of those data sets. How did they support your, or not your, tectonic model?
Yeah, I didn't include them mostly because of the time I got to do that. The MT is working great, mostly because every time that there is a Blondeau formation in the Chibougamau area, the MT seems to be responding accordingly, because the Blondeau is encompassed graphitic and sulfide-bearing mudstone. It seems that it has an impact and provide a positive answer on the magnetotelluric survey.
Okay, well, it'd be really great to incorporate those data sets into that model. You know, it's you know, they're big aspects of it, and you know, it shouldn't. I'd be surprised if that went down. The Blondeau went down to sort of the depths that the MT is looking at as well, though.
Mm-hmm. Yeah.
Pierre, it's Bruno speaking. You talked about the Hébert Gneiss Dome. Where is it, and is it similar to Aujon?
Okay, on the map, it will be this. Well, you can see here, Eb for Hébert. So this is the gneissic domes here, making the boundary between with the urban barrier belts. About the Aujon, I don't know. Maybe Lucy can help later on this part, but I'm not familiar with the Hébert Pluton.
Okay, thanks.
Yeah, Pierre Bedeaux speaking. I have a question for you concerning the stellar and IOE formation. Mm-hmm. In the past, people were making a difference between the two because there's alkaline, volcanic, or trachyte within the IOE. The stellar has been dated at 2707 maximum age, whereas the IOE was previously dated at 2792 maximum age. So I'm surprised that you put these two together, saying that their age is between 2688 and 2707.
Yeah, we had to merge them, but on the okay. So on the free age in the stellar IOE, I didn't provide the exact age for each one of them in this presentation, but this one is taken from the IOE formation, and this one seems to be taken in the stellar formation. And it seems that this one is a bit younger than the one in the IOE formation. So, well, the thing is, the IOE formation is mostly defined by the presence of the clast of the alkaline volcanic rocks in the conglomerate. But if at the moment that this IOE was forming, if in some local part there was no volcanic rocks to erode, and maybe we have called them stellar because we didn't find the class.
Yeah, the absence means nothing. The presence has a signification, exactly. Because also the alkaline intrusion, or let's say so-called alkaline intrusion, like the O'Brien is 2692, or the Chevrillon 2693. So the alkaline rocks, not the flow, but the intrusion, have been dated at 2692. And that was the previous maximum age of the IOE formation. So I'm a little bit surprised that you reading what has been written in the past or talking with Réal or Gilles, it's always been the distinction between the stellar and the IUE, the presence of trachyte, as established by Mathieu Pichet in his master thesis. So I've always thought that this distinction was a key element to between the stellar and the IUE.
Yeah. Well,
Sorry, Pierre, we gotta move on.
Yeah, sure.